Because there are literally millions of organic compounds, it will be impossible to remember common names for all of them, right? So you must have an IUPAC systematic method for naming them, although some common names still exist. There's going to be like a lot of ways to do this. So just make sure that you are making and coming up with your own way. I'm going to be showing you my way. The book might show you something else. The goal is to organize yourself. And I want to make sure we're starting off with some kind of foundation, which is just naming organic compounds in general. And then once we have those names in general, then we can make specific changes based on each family that's attached. And so for me, what I do is I take any organic compound and I break the name into three parts: prefix, a root, and a suffix. We're going to go through each part and then we'll get some examples as we go along. The root of an organic compound name is going to be based on the number of carbons in the longest continuous chain, branch, or ring, right? So we're going all there. Think in any kind of catenation, we're going to take the longest continuous chain. What does that actually mean as far as roots? And once you figure out your longest continuous chain, we'll talk about that later. So let's do an example. As you can see, we have a carbon here, here, we have a bunch of carbons in this overall organic compound. Now, the goal is that the roots is going to allow us to figure out the number of the longest continuous chain. So what we want to do is actually start counting these carbons. So I have carbon 1 here, 2, 3, 4. If I was to start my counting here, I would call this a 4-carbon chain. What about the fact that there's 3 other carbons here? Is there another way I can actually count these carbons? That's the goal, okay? And the answer will be yes. Instead of stopping at 4 here, I can continue on with 4, 5, 6, 7 here. And so, since I have one long chain that is 7 carbons, then I have to think of a root and a name associated with that root that's going to allow me to tell you exactly what that number is. So for number 7 carbons, the root is going to be hept. That means that no matter what the name of this organic compound is, the root of it is going to be that long carbon chain. And so we see that these 7 carbons make up the longest continuous chain that we can create. If I was to start numbering on the other side and put like a carbon 1, 2, 3, 4 here, it will still be the same thing, which is why I continuously went across. As you change the number of carbons, you're going to change the name of the root. So 1 carbon, you're going to have meth. 2 carbons is eth, prop, bute, pent, hex, etc., etc. So the goal is, this is definitely one of those flashcard moments where you want to make sure that you have organic compounds or name an organic compound on the front, and then prefix, root, and suffix on the back with different examples. Okay, folks? What else do we notice? We notice that, yes, we counted our carbons in a long continuous chain. We still have this carbon here. So what is that? We're going to talk about that as we go along. That's going to be attached to the prefix, and we'll get to that later, okay? So we talked about the root. The next part is going to be the suffix, okay? The suffix indicates the type of organic compound or a key functional group that that molecule possesses. So if you have a double bond, then your suffix will be the ending ene, which is going to be ene, and we'll talk about that in the future, okay? So that means that if I have any double bonds in my overall organic compound, I will leave it as ene. We know it's hept, because we already counted that 7, 1, 2, 3, 4, 5, 6, and 7. And now if we wanted to know the ending, we would have to say, what type of organic compound is this? Well, as you can see, it's only carbon-carbon and carbon-hydrogen bond. That means that we're dealing with all single bonds. And so we're dealing with something that's going to be an alkane, just from us reviewing what those hydrocarbons are, okay? So that means instead of just hept, I will add to my root and put ane as my ending. So this is actually heptane. But we still have to account for the CH3 group, right? We still have to ask ourselves, wait a minute, what is this CH3 group? And how am I supposed to learn about naming that? And that's going to be next. So recently we talked about what the root is, which is going to tell you the number of carbons. And then we also talked about the suffix, which is going to tell you the family or the group that that particular organic compound belongs to. For our example, we counted the longest continuous chain. Remember, the root has to be the longest continuous chain of carbons. So we counted the longest continuous chain as hept. Okay, and then we ended it with ane because it's only made up of single bonds and carbon-hydrogen bond. That's how we're able to get the portion of the name heptane. But now we have to account for the CH3 group. Now, as you can see, this CH3 group is going to be attached to a carbon atom, okay? And this carbon atom is the one right here. So we have this carbon atom is attached to a hydrogen, another carbon, and then it's also going to be attached to the CH3 group as well. So as you can see, this is going to be attached to those 2 carbons, the hydrogen, and then the CH3 group. So anytime you already have your parent chain consolidated, that's usually always going to be the first thing you do is figure out your longest continuous chain or your root portion. And of course, you can go ahead and do the family or the suffix next. So once you have all those details, anything that's still attached to the parent chain, Okay, anything that's still attached to the parent chain or branching off of a carbon on the parent chain is called a substituent. What is a substituent? It simply just substitutes a carbon-hydrogen bond for a carbon and something else bond. That can be another alkane, that can be, as you can see, a CH3 group, etc., etc. Now, when it's a halogen, we'll have a specific way to name it. But when it is groups that are just simply going to be other carbon-hydrogen groups, then guess what? They have their own name, and they're also going to be called alkyl groups. Alky, because it's going to be a part of something that has carbon-carbon and carbon-hydrogen bonds, which are like the hydrocarbons. And then il is going to be the suffix here, because instead of just saying, oh, I have a root or a suffix, now we have to add more details and say anything that's attached to my parent chain has to have its own name as well. And it makes it a little easier because any root that we talked about, methyl, ethyl, propyl, heptane, like we see here, they also can become alkyl groups. That means as long as I have my parent chain, anything that's attached to the parent chain as a substituent can be an alkyl group. And that's also going to depend on how many carbons are there. So there's only one carbon here. So one carbon is meth, and then we'll put the ending methyl. So that means there is a methyl group attached to whatever number carbon that we have here. Now, we've already numbered ours before, right? Let me go ahead and do that. We already numbered ours before. We know that this is carbon 1, 2, 3, 4, 5, 6, 7. So when it comes to a prefix, there's a little bit more details you have to have. One, you have to know how many carbons are going to be creating this overall substituent. And then with that, you have to make sure you have the number of carbon and then end it with il. If it's going to be a halogen or anything else, you just simply will write that and we'll see more details as we go along. Okay. So I know that I have a methyl group. The next thing you have to do when it comes to prefixes is you must have a location. So of course you can have the name of the actual substituent and you need a location. So the location is going to be based on the carbon that it's attached to in that parent chain. As you can see, we have a carbon 4 here. So we have to write 4-methyl, end our name with heptane. Okay, so 4-methyl heptane. The 4 is coming from the actual location of the carbon. The methyl is telling us the exact type of substituent. Heptane is what the actual longest carbon chain is. And ane because we have an alkene that we're dealing with. So these are the 3 parts here. Now, there's a little bit more details we have to talk about. For example, anytime you have a number next to a letter, you must have a dash line in between. But if it's 2 letters, you don't have to have a dash line. Another thing with prefixes is sometimes you can have more than one. So say I had another CH3 group here. Then I would have dimethyl. But it will still be on carbon number 4. So I'll have to keep that in mind. And because there's 2 of them, I would have 2 numbers. Let me just rewrite that. Dimethyl, right? I would have 2 numbers here. So if I had another methyl group here, I would have 4,4-dimethyl. If I had 3, it'll be trimethyl. Tetra would be 4-methyl, for example. Okay, so the goal is that you're actually making sure that with prefixes, you have the location of that actual, where that actual bond is happening. And if you have more than one, then one thing you need to do is make sure you have a number for each of the ones that you have and also a different prefix. Now, another thing is I just told you that when you have a number and a letter next to one another, you want to have a dash mark. But when you have 2 numbers, you simply just write a comma. So there's a lot of little details that we'll kind of keep on adding on to the rest of the videos as we get more, I would say as we get more examples, okay? So just to reiterate, the first thing that we did is we got our root. We figured out the longest continuous carbon chain, 1, 2, 3, 4, 5, 6, 7, okay? Once we had 7, we knew that's going to have the prefix hept. We also figured out our suffix or the family it belongs to, which is alkanes, which is going to be ane. Okay, that's going to be our ending. And then we have the prefix, which is basically anything that's not on the carbon chain, on the parent carbon chain, we have to consolidate. So this is going to be a substituent. It's only made of 1 carbon, so that's going to be meth. And it's going to end in the YL or il ending. Okay, so now I have to make sure that I have that methyl written down, and I also have to have a location for that methyl group. And I simply just bring down the full name. So the name of the molecule we've just been seeing is going to be 4-methyl heptane. Let's get some more practice.